Hey guys, this is Mrs. Harbin, and we are beginning Chapter 4 of Algebra 1. In the previous chapters, we've been looking at equations. That's where one thing is equal to something else. And we've been solving for unknown values using what we've learned about equations. In Chapter 4, we're going to take a look at inequalities, which follow a lot of the same operational rules as equations, but they don't mean the same thing as equal to. So let's take a look at what I mean. For objective today, you, the student, will use the trichotomy property to interpret inequalities and graph inequalities on a number line. Now, you should recognize this prefix here, tri meaning 3. And so when we talk about the trichotomy property, we're going to learn about 3 things that are true of every set of numbers. Let's start first with the definition of inequalities. An inequality is a mathematical sentence stating that two quantities are not always equal. Now, this isn't the first time you've heard of inequalities, so let's review those symbols. Our first symbol is less than. For example, 4 is less than 6. Our second symbol represents the expression is greater than, and an example is 5 is greater than 3. Our third symbol represents not equal to. For example, -2 is not equal to 4. This symbol represents is less than or equal to. Notice that we've got the less than part and then we've got a little bar underneath. That's the equal to part here. -1 is less than or equal to 8. And finally, greater than or equal to, 6 is greater than or equal to 0. Remember, it can be one or the other. You may be thinking, but -1 isn't equal to -8, and you're correct. This symbol does not mean equal to. It's one or the other. It's less than or equal to. And in this case, it does meet the requirements. It is less than 8. So be careful. This doesn't mean it's both. It can't be both less than and equal to. It's one or the other. All right, now that we've reviewed those symbols, let's take a look at the trichotomy property. Remember, trichotomy means 3. And when we look at a set of numbers, there are 3 possible things that can be true. If A and B represent 2 real numbers, then one of these 3 things must be true. Either option 1, A is equal to B, option 2, A is greater than B, or option 3, A is less than B. That is our trichotomy property. It says that these 3 things must be true of any 2 numbers. Let's put some real numbers in there and see what that means. So we have, let's say, the numbers 3 and 5. And one of these must be true. Either 3 is equal to 5, which it's not. 3 is greater than 5, it's not. Or 3 is less than 5. Ding, 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 we have a winner. That's the one that's true. So when looking at any 2 numbers, the trichotomy property states that one of those expressions must be true, one of those 3 expressions. An inequality can be negated by putting a slash through it. Just like we saw equal and not equal to, we can put a slash through our inequality symbols to make them not true. For example, x is not greater than 5 can also be rewritten as x is less than or equal to 5. If it's not greater than 5, then it must be one of the other 2 options. Remember, there are 3. That's what our trichotomy property said. So if it's not greater, it's either less than or equal to 5. Let's take a look at some examples. Let's state an inequality statement that's equivalent to not less than or equal to. Remember that there are 3 choices: equal to, greater than, and less than. And this says it's not less than, and it's not equal to. So which option do we have left? It must be greater than. So x is greater than y. So when you're asked to write an inequality statement that's equivalent to another one, be sure you check out your 3 options and that trichotomy property to see which one of those is actually true. Any value of the variable that makes an inequality true is called a solution of the inequality. So we'll be looking for solutions in this lesson. Now, in algebra, when we are solving for an equation like we did in chapter 3, we often ended up with just one solution. We can have more, but so far we've just ended up with one solution, like x equals 7 or y equals -3. With inequalities, there are typically an infinite number of solutions to each inequality. Let's think about why that's true. If we have the inequality x equals 5, we have an infinite number of solutions that are greater than 5. 6 is greater than 5. 7 is greater than 5. 8, 9, 10, 11, 12, and continuing on to infinity, x could be any of these values. So we really have an infinite number of solutions. Let's take a look at a plus 3 is greater than 6. We're going to plug in these three numbers and see if any of these numbers are solutions. So when we plug in 2 plus 3 is greater than 6, we get 5 is greater than 6. That's not true. Remember, a solution has to be a true statement. So when we plugged in 2, it did not give us a solution. When we plug in 3 plus 3 is greater than 6, that says 6 is greater than 6. Again, that's not true. 6 is not greater than 6. It's actually equal to 6. So 3 did not give us a solution. When we plug in 4 plus 3 is greater than 6. That simplifies to 7 is greater than 6. That is true. So we only had one solution for this inequality from the set of given numbers. 4 is the only one that was a solution. It's the only one that gave us a true statement. All right, let's try another one. Try this one on your own. Pause the video, try it on your own, and then unpause when you're ready to check your work. Which of these are solutions? When we plug in 2, we get 6 is greater than or equal to 4. That's true. When we plug in 3, we get 6 is greater than or equal to 6. That is also true. And when we plug in 4, we get 6 is greater than or equal to 8. That is not true. 6 is less than 8. So only 2 of our numbers were solutions. When we plugged in 2 and 3, it gave us true statements. So 2 and 3 are solutions. All right, try this one on your own. Pause the video and then unpause when you're ready to check your work. Let's plug in our numbers. 1 minus c. First of all, we're going to rewrite that using an inequality without a slash through it. So our trichotomy principle, remember, less than, greater than, or equal. This one says it is not less than, so it must be greater than or equal to. And that's where we get this symbol from. Now that we've rewritten that without the slashed through inequality symbol, let's plug and chug. Plugging in a 2, we get a true statement. Plugging in a 3, we get a true statement. And plugging in a 4, we get a false statement. So again, 2 and 3 are solutions. 4 is not a solution. Let's talk a little bit about graphing inequalities. When we're listing possible solutions, remember we said that there are usually an infinite number of solutions, so it's really not possible to list all of the solutions of an inequality. If I asked you to list for me every number that was greater than 5, you'd be here the rest of the day and to infinity listing every number greater than 5. So in order to show all possible solutions, we can make a graph on a number line to indicate that our solutions are going to be infinite. Remember, a number line is written this way with 0 in the center, our origin in the center, negative numbers to the left and positive numbers to the right. When we're graphing an inequality, we're going to use a solid circle when the number, or use an open circle, sorry, when the number itself is not part of the solution set. It's open, it doesn't contain that number. For example, 5 is greater than x is usually rewritten as x is less than 5. And to show all the numbers that are less than 5, that would be 4, 3, 2, 1, 0, 1, 2, etc. We're going to do an open circle at 5 and go to the left. Less than goes to the left. Less than goes to the left. The reason we have to start at 5 is because right here, if we're doing decimals, 4.99 is less than 5. So we need to make sure that our number line includes, or our graph includes, 4.99 and everything to the left. So this graph on a number line shows us all the possible solutions for x is less than 5. When we do less than or equal to or greater than or equal to, we do have to do a solid circle because we do want to include that number. So for x is greater than or equal to -3, it includes equal to, so we're going to put a solid dot at -3. And because it says greater than, I remember that there's an R in greater, and I'm going to go to the right. So greater than or equal to -3, solid dot at -3, and then we draw to the right. Again, we put a little arrowhead here at the end to show us that our solution set is infinite, so that it's going to keep on going past 5. Right? How do you think we would graph this one? X is not equal to 2. Well, let's think through this logically. What are some numbers that are not equal to 2? 3, 4, 5, all of those are not equal to 2. What about -3, -4, 0? All of those are not equal to 2. So it looks like our graph has to include every number except 2. So x is greater than 2 or x is less than 2. Any of those numbers would be a solution. So we're going to put an open circle at 2 because it's not equal to 2. And draw an arrow to the right for all the numbers greater, like 3, 4, 5, and draw an arrow to the number for all the numbers that are less, -3, -4, 0. All of those numbers are not equal to 2. Let's take a look at this side. Clearance, $9.99 and up. Think about how we could represent this information with an inequality. Let's let C equal the price of the item. And what do we know about the price? We know the price is $9.99 and up. So the price of our item is going to be greater than $9.99 or equal to $9.99. It starts at $9.99 and goes up. So the price of the item will be C is greater than or equal to $9.99. Let's write an equation that models this situation. Maximum occupancy not to exceed 225 persons. How could we write that as an expression? Let's let P equal the number of people. And what do we know about the number of people? Oh, we know it has to be either equal to 225 or less than 225. It cannot be greater than 225. So again, going back to our trichotomy principle here, it can be less than 225 or equal to 225. It cannot be greater than 225. So we would write that as P is less than or equal to 225. Today we use the trichotomy property to interpret inequalities, and we graphed inequalities on a number line to show the solutions. Because it's not possible to write an infinite number of solutions, we can use arrows on a number line, greater than or less than, to show us the possible solutions. If you guys have any questions, be sure to ask me next class.